Hi, it's Gadget UK here again. As you can see, this time I'm looking at a PCB that I've created. So following on from the MV1B repair I did there, that had a surface mount SP1, the main ROM, the main BIOS for the Neo Geo there. So in order to fit a Unibios or a Diagnostics ROM, you need some kind of adapter. Because otherwise, you're going to be soldering dozens of wires to the PCB and having a floating ROM chip. It'd just be an awful mess. So you can already buy a ready-made adapter board similar to this. It works the same way. I don't know whether the ROM's in the same orientation or what. I forget who makes it. I'll post his name up there and I'll stick a link in the description above. But he's based in the States, and in the past he's only done a certain quantity, of these boards, and then he sells out, and it can be months or even a year or more before he does his next lot. Now that might have changed in recent times. You may be able to just buy them readily available from him. I'm not sure, but with the shipping and the import taxes and all the rest of it, it was just far easier to just go and create my own, I thought, at the time. So as you can see, I've had it manufactured in a black PCB here. I'm not sure what colour would look best, but the idea is, I'll show you, we've got the PLCC sockets here. So this is the underside. I've put a position there for a cap for this chip, so it's super close to the where the BIOS would go. This is probably not going to go straight on because some of these pins are bent on these cheap sockets. Can you see that? Yeah, they are super cheap. They didn't come with any of the proper packaging, really. It's just that single plastic bag. But anyway, once I've straightened the pins, like I said, the socket will go on that side there. The idea being that it will clip on top of the 68K. Got to make sure I get it the right way around with regards to the notch when I'm mounting it on the underside there. If that makes sense, because you've got your, can you see a better sort of chamfered corner there, I think it is. But the pin arrangement here means that you can move it either way around, so I didn't need to worry about that at all. Just needed to make sure that in relation to the socket being that way up, that I had the right connectivity here. Now there are a couple of connections you need to connect wires from here to the motherboard, and I guess there's a few places you could connect those to, but the ideal solution would be to just use hot air. Use the A10 here. We'll remove the original SMD ROM, and that'll free up obviously all the pads there, and I can just run a wire for the chip select and one for the output enable straight to where the original SP1 was. And if we mount that, let's say on the underside there, put a socket here. I did print a copy of this after I designed this in KiCad, just to make sure it would physically fit, and it seems like it should be okay. So provided I've not missed a connection, provided it's been manufactured okay. That's a funny coloured wire there, can you see that? Some of these may have defects, I'm not sure. Yeah, provided all that stuff's okay, hopefully it should work. So I'll start assembling this now, I'll show you. So I straightened the pins there using some needle nose pliers, and as you can see I've got the chamfered edge there towards the cap. Actually, if I just flip this over, just need to just solder that on there now. I'll probably do diagonally opposite corners first, make sure it's totally flat and flush, and then solder the remaining connections. Yeah, that's looking pretty straight, so I'll just solder the remaining connections. I won't bore you with that. So the bad news is there is a problem with this board, actually. After I got the socket on here, I did some connectivity tests, and I found it was like, if you look at the data bus as an example, it was like the second from the bottom was connected, then it was miss one, that one was connected, miss one, the next one was connected. And what's happened is, the pin ordering here is super critical. It's really important when you look at the chip from this side up, the socket this way up. When you flip it over, the orientation of some of the alignment of some of the pins is flipped, so you end up joining incorrectly, if you see what I mean. So like say every other one here was okay and the other ones weren't, because they were corresponding to different pins on here than if the socket was on the other side of the board, if that makes sense. It's just something I totally overlooked. So as you can see, I desoldered that socket, I didn't get as far as putting the dip socket on here because I was just doing that connectivity test and then realised straight away there was a problem. So yeah, back to the drawing board. The other thing is the ground plane's not on here. Somehow it's gone. It seems to have disappeared after I uploaded it to Dirty PCBs. It's no longer there. They haven't added it. So I need to revisit that as well, actually. And in fact, the ground plane wasn't very good on here, so I might just revise it at the same time as I, fix the layout issue here with the socket needing transposing, the pins. I think what I need to do is number all the pins up, so I know exactly what the pin numbers are, and then flip the image in Paint, because when you flip it in KiCad, it doesn't do a proper flip. I need it to actually be the other way around, kind of thing, so that I can see the pin numbers under here, and that way I can then correctly map them to the destinations. So my revised PCBs have arrived. Let's hope I've got it right this time. Let's hope they've got it right on their side. Yeah, so it's looking more promising in terms of a ground plane. I think I've managed to get the ground plane on there now. I'll perhaps explain how I managed, what the issue was with that actually a bit later on. It was something to do with KiCad and how you export. But yeah, I think that looks okay. So I've had an interesting challenge with this actually. These sockets, if you think about it, the chip is designed to go in this way, and the way those chips are assembled, the pins come out sort of almost the side of the top, if you like, and go down the chip underneath it and are sort of hooked on the underside on a PLCC chip. So, I'll show you. If we have a look at the CPU, you can see exactly what I mean. If I just zoom you in a little bit, and you can see, well, you might be able to see if it stops blurring. I did the corrective work here. I tinned up, if you remember back when I did the repair of this 1B here, there was a wide tray. Yeah, so if you look at the PLCC chip here, you can see what I mean. The pins don't come out from the top. They come out sort of just above the halfway line, go down to the bottom, and if you looked on the underside of this chip, it bends under and is folded up on the underside of the package. So you've got quite a big gap at the top here, and obviously it goes right down to the very bottom. So when that chip is in one of these sockets, you've not got an issue. As soon as you go the other way around and you start sticking this on top, you've got a huge problem. The other thing I'll point out, if I show you one of these, this one that's not been modified, can you see what I've done? I just really carefully used a scalpel and then a file just to chisel off, and it's super soft, this plastic actually, it's super easy to do. Chisel off the little indentations there so that the chip can fit slightly further into the socket, which you need to accommodate the height difference there, because this is reverse mounted on the chip. And then the other thing, and I thought there must be another technique here, because what I found, like you clip this on and it just comes straight back off, it just pops back off, you can't get it to stay on. So I thought, I'm missing something here. How are other people doing this? They must be shaving the edge down. Can you see, if I just put that up to the camera there, you've got a good millimetre at least of height on the lip all the way around. I wondered if someone was sticking them on a sanding belt or something, or even what do you call it, one of those mill things, just milling it down on the four sides in equal height of about a millimetre. So I did some research actually, and I thought, they're doing this on the Viper and other things, for the Amiga. Is it the Viper? Vampire, yeah, I'm losing my mind. The Vampire for the Amiga. I thought, how are they doing it? And the way it turns out, they're actually doing what I thought, they're grinding down the tops of the sockets there. So I don't know if you're going to be able to see the difference there, but if I just put them side by side, can you see? I've ground, if I just put them exactly side by side, yeah, you're not going to be able to see it. It looks like I've shaved nothing off, but trust me, I have. I've shaved, a good millimetre off the height there, just with a file, flat file, all the way around. They're totally straight, nice, perfect straight edges. But the net result is, when you come to clip this on, I should be doing this on the ESD mat really, you will see that it makes a nice snap fit. If I just get it in place, that's it, and it stays on. So doing it that way and just soldering a couple of pins on each side, I've been able to do some connectivity tests, because that's what I was interested in with this new V1.1 board, to make sure that the connections here are going to the right places on here, you know. So, for example, one of the things I did yesterday, I tested the continuity from the second pin along here, and it came to that pin there, and then I started going along this way here, and I've got connectivity all the way up here as I should have. The grounds are somewhere like here, I think, and they're joined up to one of the pins here, which is ground, and I tested it to there as well on the test pad, and then I tested the 5 volts, and the 5 volts is connected correctly to this pin here, this pin, and this pin, I think, yeah, and one up here, and again, you know, down here. So I know my +5 and my grounds are okay, my data bus is okay, I need to do the address bus next. So the only other thing to do is to remove this chip here, the ROM, with some hot air, and I'll need a wire coming from the output enable pad to one of the, you know, the output enable pin, and the chip select pad to the chip select pin. This isn't really the right kind of component footprint to use here. I just wanted a pad on either side, but I just used the jumper one. You've got one over here that's not used for anything really, but anyway, nevertheless, it should work. So I think I'll just finish resoldering the rest of the pins on there, and that'll make the testing the connectivity a bit easier. But I'm confident that this is correct now. And you may wonder why I'm going to that extent of testing the connectivity that way. You'd think that I'd have a good level of confidence in this board, and I do. But what I don't have is a good level of confidence in the mapping of that socket. So what I mean by the mapping of that socket, I'm talking about it's being reverse mounted. Now, something worth pointing out, if I just say, if you look at this one here, let's look at this. It's like, you know, you've got the pins going all around the chip, yeah? One row of pins around the chip. Yet here, you've got 2 rows. You know, you've got this 2 rows. And that's important because it kind of goes like first pin, second pin, third pin, fourth pin, fifth pin, sixth pin, seventh pin, eighth pin. And as soon as you flip the profile, if you don't take that into account, that the fact that, you know, you're starting on this one here instead of that one there, whereas on this one, this next side, it changes. You can only have this one way, and that's the mistake I made with the first one. I was thinking the socket normally would go like that on the PCB. We're going to stick it on the underside. It won't make a difference, but actually it does, and it's just something I just didn't think of. So yeah, it's super annoying that you've got to sand the edges of these down, because, you know, it's a bit analogy. I don't like things like that. I like nice digital solutions where you can fit a socket on there and then that's it, it's done, it works or it doesn't. Yeah, anyway, I might manufacture the rest of these boards up and offer them out, but it's going to take me a while to do. I want to make sure that, you know, they're clean and tidy and presentable. But I mean, that was fairly easy to do because, as I say, the plastic of these sockets, these are quite cheap, and it's easy to just, you know, to file it down. So I've got the PLCC socket soldered on there now. The next thing we're going to do is get the ROM chip the right way around. And incidentally, I haven't got the profile of the chip on the underside here. I might revise the board and stick that, but you can see where the angled notches here, the chamfered bit, and that corresponds with the same over here, you know. So if you flip it over, like, say we've got it on this side here and here. So yeah, you know, you can assemble these fairly easily once you've ground the socket down, but then that's going to go that way up, and then the chip can fit in here. We can do the cap last. If the socket was on this side, I'd do the cap now, just for clearance reasons, but there's enough space there, as that is, you know, once this has been soldered here, to get the cap on at the last step. So again, we'll solder corner points first. And then press the sockets like that from the other side to make sure it's flat. Press again. Yeah, I can clean up that solder in a minute. And then just solder the remaining points here. Now bear in mind, there are no electronic components on this PCB, so I'm alright doing this on the carpet at the moment. So there we go, there's a socket soldered on. I'll clean all the flux off both sides of this in a minute once we've got the cap on. Now you may be wondering, why does this need a cap? Surely there's a cap for the ROM on the board already. Yeah, there is, but remember, the cap needs to be as near to the VCC ground connections to the chip itself. So this is not going to be in the position where the original ROM chip is on the board. It's hijacking the power and ground from the 68K here. So it is super important we have a 100 nanofarad cap on there actually. Now I can't remember what size footprint I went for when I laid the board out, but I've got some 1206 caps here, which, yeah, they'll fit fine. Maybe I went with 1206. So we'll just peel the end of this roll off here. Just double check that it is 1206, yeah, 100 nanofarads, yeah. Yeah, I've used one of these already, I think. You can see one's missing on the end there. We'll just tap that out, put the caps to the side, lob that onto the board. It's gone under the socket almost. Yeah, these things are so small and fiddly to deal with. In fact, I'll just move it to the side. I'm going to get a bit of flux on there first, actually. I mean, I've shown this sort of stuff on my videos before, but to be honest, I think I tend to skirt past it recently. Like on those MVS boards I repaired. Oh, we've got flux all over the place now. Is the cap? Yeah, the cap's stuck to the flux tube. There we go, it's back on the board again, I think. Yeah. Just because I usually skirt over it showing you how to do this, because it's so fiddly to try and capture on camera and actually see what I'm doing and try and fit it at the same time. So let me just try and move this, there we go, into position. Let's slide it around. Come on. Some people prefer to turn up the pads first of all, and then, you know, stick it on there when there's solder on the pads. And there's no real right or wrong way of fitting something like this. It's use your own tools and skills to the best your advantage, I guess, really. But if we just hold it down like that. Yeah, that's not too bad. Yeah, let's just do the other side now. Yeah, it's hard to see from this distance whether that's in position, but it looks like it's probably okay. And we'll just do some fresh on that side. Yeah, that's not too bad. So, yeah, I don't know, you can see that it's pretty straight on there. All I need to do now is get some IPA and a toothbrush and clean this PCB up. And in fact, before we use a toothbrush, I tend to use a cotton bud first of all, because you can get the majority of the flux off this way. You know, if you just go either side of a socket like this, socket pins. It's going to be a bit more difficult on the PLCC socket because I can't get in between the two rows of pins, but nevertheless I'll still do this on the outsides of the pins, as you'll see in a sec. Then we'll go over with the toothbrush. Let's clean around that cap, there's lots of flux around that. Just, you know, next to where you can. You know, you can't get in between the pins there, but you can with the toothbrush. I think the other thing I'll do while I'm here is shorten that wire there as well, actually, because you can see it comes down here and then up. I'll just make it curve around like that, and then I'll stick a label over that scratched bit from where I sorted this video out to say it's been fixed. I need to get some nail polish back over the area I fixed there, but anyway, the next thing we need to do is remove the ROM. So I've got my station incidentally set to about 450 at the moment. Now, some people might think that's too hot, but I found it's just right for these MVS boards. You don't need a long, I don't know, a minute or two on each side. You know, just keep alternating sides. But in general, you'll spend about 3 or 4 minutes in total. But it's going to vary. I'm using an Aton 858D. One of the reasons I don't usually mention temperature is because you will find that different equipment measure, gives you different readings. It depends on your airflow as well, your airflow speed, that's a factor. So you can't always just go off what someone tells you unless you're using exactly the same kit. I'm also in a very cold room here actually as well, and you may think that doesn't make any difference whatsoever, but it does. The ambient temperature, the temperature of the board and the air around the board is a huge factor. So at this time of year I tend to have to use slightly higher temperatures to remove things. Now incidentally, the other thing you could do is you could just lift the output enable and chip select pins. You'd need to feed, let me think about this, I think you'd need to feed the chip select with a high or something on the ROM to disable the onboard ROM, but you could leave it in place. But I want to actually just remove it and pull it off there. If anything, it's useful as a spare part should I come across another one of these boards that needs a new ROM. And at least with the dip adapter there, assuming it works, I can't think why it wouldn't unless there's one pin not mapped correctly, but it seems okay. Yeah, I was going to say, from this point on, this is going to have a dip socket anyway, so it doesn't really need it. You can hear it clicking a little bit as it reaches temperature. Gotta hope I don't damage any heat pads. But, you know, I'm not levering this, I'm just using the weight of the tool itself just here. Same old thing I always say. There's only so many ways you can say the same thing over and over on your videos. It's coming off. Struggling to get a grip on it. There we go. Okay, it's off on one side. It's hanging on this side, it certainly is. Come on, it's because it's quite long as well, it can make it a bit more challenging. There we go. I'm kind of glad I removed that, look how dirty it is underneath. And finally here, the toothbrush. So there we go, it's about as clean as it's going to get for the moment. It's super hard clean these black PCBs. I think I wouldn't go with black again actually for that reason. But nevertheless you can see it looks okay, our little cap's on there now, socket's okay on both sides. So I removed all the solder from the pads where the SP1 originally was. Added a bit of flux and solder just to that single pin there. It's quite hard to do because I'm so far away. A single wire. So that wire needs to come round here and up to the output enable pad. Sorry, you can't quite see that. Wants to go to the output enable pad there, and then pin 2 down here wants to go to that one, which goes to pin 2 on my dip chip. And there we go, all done. So like I say, the end pin there is the output enable, so it wants to go to the output enable, and the chip select is the second pin, pin 2. So what I'll do is I'll lift this off in a minute just to show you how clean that is around there, and we'll clean it with some IPA because I've not cleaned off the flux yet. I'll do the same thing here because I've not cleaned the flux off there. But right now I want to get a Unibios in there and go and give this a try. So I figure why not try it with the Neo Geo ROM first actually. Now switch it on. Oh yes, mission accomplished. Fantastic. And with the Unibios as well, that's working, so test some games out. So it's been left on for a good hour actually, no problems at all, it's rock solid, I've had a few plays on it, no issues. So I think for the next revision I would have jumpers actually to detach these wires. I mean I could solder jumpers on their little pin headers and little sockets. Maybe have just a 2-pin JST for the 2 and then you could just plug it in and have your cables coming out. That might be how I would do this, but yeah, you can see it's pretty easy to clip it off, just carefully, just flip this over. Yeah, I can't get much cleaner than that, but you can see we've got nice clean solder points there just on those 2 pads. So there we go, I won't be leaving the Unibios on there because this is my test Unibios. I think it's the free version I've used to test with, but I have 3, I think, licensed versions of the Unibios I use on my main working systems, like one on my AS, one on my main MVS, and I think I've got one on my 4-slot, I can't quite remember now. So yeah, if you can, support the Unibios by licensing it. You know, it's only like €20 or something, and he'll send you out a chip. Raz will send you out a chip that's programmed and stuff. So And then you're in line for free future updates as well. I think they're on version 3.4, might be on Unibios 4 now actually, I think it is. The one with the 161-in-1 pick and mix mode or whatever it is, it's like a menu for the 161-in-1. So yeah, that's quite nice. I haven't got around to upgrading mine yet. I'm still on 3.3 or 3.4 I think. So you can see I tidied that wire up there. I just lifted it up a bit so it wasn't bent right down, and I re-secured with some nail polish there. Got a label over those horrible scratches. It's a little bit cleaner than it was. I cleaned it between some of the chips that hadn't been cleaned previously. Yeah, so it's looking alright, that board. So apologies about the refresh rate, but I just want to show you the issue I had with exporting. So you can see the PCB layout there, and if I just highlight that's the bottom layer, that's the top layer. You've also got a 3D viewer built in here as well, which is super useful. So you can look at your board and rotate it. I found this really useful in the design stage of being able to just quickly flip the board around, follow the traces, check wires, etc., and just visually inspect it to make sure it looks okay. And you can see, I've got a lot of ground plane here. Now, in that first version, the ground plane wasn't as tidy and as neat and as optimised as it is in this version here. Actually, it came out quite well, and that was from my experience of the original board. So in some ways I was lucky that that first one didn't work because it wasn't that tidy. I mean, the one thing that could be improved on here is to have some ground plane between these traces and these traces at the top. But there's a lot of ground. It's not a particularly thin board, but a thick board. It's not a particularly thick board, but you've got ground plane everywhere else. I made sure that I stitched. I don't know if you can see these little bits here. You see these bits of ground plane here. I stitched these with wires through to the other side. So it's useful occasionally just to come in here and then just check, just to make sure that where you've got wires going through to stitch the grounds, that you've not accidentally joined up somewhere else. And the other aspect to that, when you want to stitch the ground planes, is to just swap between the layers here. So if you're looking at, say, sticking, I don't know, let's say that one there, I don't know if you can see where the cursor is. If I just switch layers, you can see what's underneath. It's just solid green, it's solid copper. So yeah, it's quite easy to go, okay, yeah, I can position one there and then just choose the via component, plop, done. And then just maybe flip again just to make sure it's in the right spot. But it didn't take long. I would say I spent probably 2 hours at Christmas just throwing this together. But as I say, the initial version 1 was not that great really. There were some issues. But the point is, it goes a specific way. So as soon as you flip the profile, you stick the socket on the other side, you mess up the orientation, because the socket is, it goes from one side to the other in terms of the ordering there, if that makes sense. Now, coming back to the issue I had with V1, the ground plane is perhaps in my mind, is one of the last things to do, actually. And I added the ground plane finally, just put a few stitches there, like little connections to join it up on either side of the board. I think there was some. If I have a look at the underside here, let's see if we can zoom in a little bit. Yeah, so can you see that pin there? At the sides of it, I'll zoom in a bit more. There's a couple of ground connections joining up to the ground plane. So, and it's the same on the other ground there, one or two of the places on there. There's very little needed to do, and then I could just finally do the stitches, or at least the wires here, on both sides to join the top side to the bottom side on all the ground connections, and that's fine. That approach seemed to work well. The first time I did it, I spent a lot of time messing with the ground plane, sort of midway, and that's just a huge mistake. I would do it as the very final step, because then you get less issues. Click plot, and then in here you click the plot button, and if you look at this message here, zone fills are out of date, refill. Now this is a critical thing that I wasn't aware of, and there might be a reason why I'm getting this, that if you're using KiCad the proper way you might not get it. But yeah, I'm just picking this up as a go, really, KiCad. And if you choose yes, just watch what happens. Did you see the board changed? Something's different about the board. And if I close that, on first inspection you think, well, it looks alright, I don't really see what's changed. But if we go into the 3D viewer now, let me look at that. Yeah, oh yeah, I can see what's happened straight away. I don't know whether you can see the difference. Just let me move the camera. Yeah, look at these vias here. For example, these were stitches between the ground plane. Now this is ground plane. It's stuck a silhouette, it's stuck an outline around everything, every single thing on the board, including the things that were stitching up the grounds on the other side. So that was one of the fundamental problems I had with the V1, because when I then sent those Gerber files now, uploaded them up to dirty PCBs, I didn't spot it, and of course they produced that board, sent it to me, and there's no grounds on it. I'll show you in a minute actually, you can see there's no ground plane, and the grounds are missing to the chip because of that. But yeah, if we close that down, if I just close that project, I don't want to save it. And we just launch up again, yeah, there we go, it's back as it was. If I view in the 3D viewer again and zoom in, you can see the ground stitching here is correct now, it's back in place. So yeah, that's something you need to be careful of when you're doing the plot there to create the Gerber files. Just make sure that you don't refill all any zones or whatever it is. So it may be hard to see this. This is the V1.1 board, and let me just see if I can show you. You can see, if we get it in the right light, can you see the ground plane here and the via stitching it through to the other side? And if you look at how this one turned out, bear in mind this was almost identical actually. I did have the ground plane stitches there. In fact, some of the wires are missing, because this is the other strange thing, is I did have some stitches in between these, and these had a ground plane. So that whole process there, I kind of badly demonstrated a minute ago, where you plot the Gerber files, generate the drill files, and then it updates any of the outboard outline stuff or whatever it is. That, if you choose yes, it removes loads of stuff. It seems to undo everything you've done there with the ground plane. So yeah, that was the problem with that. That's why I ended up with no ground plane. It also explains why when I did the Neo Buff board there, despite those boards working perfectly, it removed the ground plane on that as well. And it wasn't that important there, but still, it would be nice to have. Certainly on the next lot of the Neo Buff boards I have made, I'll make sure that that's correct. But yeah, you can clearly see the difference. You can see, see how it's raised here, and it isn't here. It completely removed it, which was super annoying. That's not what I wanted, which of course means, and it might be more evident on this side here, where there were grounds. Can you see this? This is where I had a bit of a fudgy attempt. This was all ground around here, and this was a ground pin, and can you see it's like coming out here, and that's where it was joined up. There was a circle here where it had not filled it, and it was joining, this pin here to the vias and the ground area, but that just looks a mess actually. So learning from that this time round when I revised it, that's a manufacturing imperfection there, I don't know if you can see that. Yeah, when I revised it, I did the ground plane last, and that I would recommend doing that. If you're designing your own board, do the ground plane last, because it just makes it super easy, so that all you end up doing is just the odd little trace. Perhaps there's one somewhere around here, I can't even see it. And you can just use the vias to stitch through to the other sides. It just ends up being a lot tidier. So I think overall, even like there, see, look, any little bits like that I was able to just stitch through to the other side. So I think overall for version 1.1 it came out really well. Bear in mind it's a long time since I created a PCB, and I perhaps didn't create anything as sophisticated as this when I was back in the day. I used ferric chloride, and you had they were like little crystal things, and you had to crunch them up and mix them with water, I think, and yeah, it ate through everything. Anything metallic, you couldn't pour it down in a metallic sink, for example. It would just eat the sink away. So yeah, I think it turned out okay. So I might make this open source. I mean, it's not hard to copy yourself, but before that, I think what I might do is just manufacture these and see if I can recoup some of the costs, because obviously it's cost me a reasonable amount to get these done, and this is the second lot. So the first lot of boards here, they're a write-off. I can't do anything with them really. Yeah, so it was a bit of a crazy mistake to not think about how the pin ordering would be flipped when you flipped it over. Anyway, hopefully you found that interesting. Thanks for watching, and I'll see you soon.